Alright, so hopefully I should be just about done with the testing on this so that I can just start running it and feel confident it won't cause too many issues. This is my 6 Maxwell supercapacitors, 3,000 farads each, and what I'm doing is I'm going to be adding in the secondary battery in order to basically keep them alive when the car is off from the internal drain of the capacitors and also the small parasitic load of the car. But what I want to do is see when it starts how much of a load it's actually going to be putting on my small battery. It's a 4.5 amp hour battery, and what I've got is I'm going to be connecting essentially just some inline fuses to the battery on the power side to the positive side of the capacitor bank, and then I have the ground wire coming to connect for the ground that will go to the capacitor bank. Through the ground wire, I'm going to be using a current shunt so that I can actually see while it's starting how much amperage it's pulling from the battery. If it pulls too much amperage, then I have to figure out something else, either a relay to disable it when it turns over, or a resistor to limit the current, or a current limiting circuit that I could try to put together. Hopefully it'll be small enough that I can just leave it in parallel without a problem. The other thing I'll be monitoring is actually the large current shunt, which is connected to the ground side of the capacitor bank. So I should be able to see while the car is turning over how much power is coming out of here and then how much will be coming out of the small battery down here. I'll finish getting it set up and hopefully it will all work out the way I have it. Alright, so on channel 1 I'm measuring the amount of amperage going in or out of the capacitor bank. Channel 2, I'm measuring the voltage right at the points of connection at the capacitor bank. And channel 3, I'm monitoring the amount of amperage going in and out of the battery. My current shunt is actually in backwards for my capacitor, so right now you can see it's showing it's taking power out of the battery, but it'll actually read the opposite. It's easy enough to fix. Once I log it, I can just switch the direction of everything, and a lot simpler than wiring it. So what I'm going to do is, the battery is fully charged and I want to get a good baseline to start. So I'm going to start the car, leave it run until the voltage gets up to that 14.4 area voltage that the alternator puts out, and then I'm going to sit and leave it equalized so that it'll actually bleed the power into the battery. So it'll be in a similar state to what it would be in the morning after you shut it off using it the day before. So right now, the capacitor bank is at 14.3 volts, and it's actually putting power into the battery at a little under an amp charge. So I'm going to wait till that basically stabilizes so that the battery and the capacitors are about the same, pull the fuel pump fuse, and turn it over and see how much cranking time I get with this setup. Alright, so I'm going to see how much cranking time I get with this setup. So here's the data that I got from turning the engine over. The first thing I have to say is that the way I had that small battery wired in, I basically had it fused with inline fuses at 40 amps, and it blew the fuses out pretty much instantly when I was turning it over. So I'm going to basically use a 3 ohm resistor and run a 4 amp fuse on it in case something were to short. The terminals on that battery are only rated for 22 amps, and I was playing with testing it, and when the car is turning over I can pull over 80 amps out while it's rolling. So that battery might not have been the best choice, but I should be able just to leave it in parallel with a resistor in between so that it'll just keep the car charged up while it's sitting there from the parasitic loads and from the capacitors bleeding down. But on to the data that I actually did get. This is the capacitors basically on their own because that fuse blew out instantly. I'm getting about 9.5 seconds of good strong cranking, where I wouldn't have any doubt it would have zero issues starting the car at any point along here. So I should be able to get at least 2 to 3 short bursts of cranking the engine in case I do have a hiccup on the first or second time. For the first 5 seconds, it actually is going to be cranking the engine over considerably faster than what the battery would, and then basically the second 5 seconds it's going to be turning it over slower than what the battery was. I stopped cranking at the point where it just started slowing down. You could keep rolling it over and possibly still get it to fire, but I was kind of looking for the time frame that it would actually give me good power, not it'll turn it whatsoever. So my original goal when I started this was to get 15 seconds of cranking time while keeping it above what the battery voltage would be, and I ended up getting 5, so my expectations might have been a little bit high, but it seems to be working quite well so far. I'm going to just clean up the wiring and basically try running the car for a number of months like this and see how it all turns out. The other information that I did get was the amperage, and there isn't a whole lot to look at here. In a previous video, I think in part 4 it was, I actually was comparing how the capacitors affect the amperage compared to the battery. It's all going to be about the same. The only thing that was interesting to me was the fact that the amount of inrush current that you can get when you have low internal resistance in the capacitors compared to the battery. It was a little under 600 amps compared to 850 amps of initial inrush current. But that's not really relevant because of the short period of time it happens in. So hopefully this project will stay together for quite a while, and I'll probably do an update in a number of months and show how it's doing still. Hopefully you enjoyed this little series that I did, and thanks for watching.